Hello everybody, welcome back to Hawk Tutor. Today we're going to be going over the channel, which we can see right here. And to do that, we're going to be going through examples A and examples B. And just to quickly open up with what the channel is, essentially all you're going to be doing is finding a function inside a function. That's when you know you have to use it. So for this, we have the e function and the x function and the exponent. Here we have our x function and a radical, which is another function that puts this 25 minus x squared inside of another function. So basically, channel, you're just looking for a function in a function, and that's how you know you're going to have to use it. So for these two examples, we can obviously see we have a radical and an e value. So that's not just what you're going to be using it for. Obviously, there's other examples, but these are just two that are very common and like to pop up. And to represent the inside function, I'm going to be using the variable u, which isn't always the variable that gets used, but it's pretty universal, so that's what I'm going to be using. So let's get started. So with part A, we are essentially going to start off with this. So we'll have e to the u power. And all u is essentially just going to be that inside function. So u is going to equal x to the fourth plus 7x in this case, right there. So u equals x to the fourth plus 7x. And then basically all we're going to want to do is multiply this e to the u by the derivative of the inside function. So if we watched the last Hawk Tutor video, we're going to know that for this inside function, you can use power rule, and it is going to be 4x to the third plus 7. So basically we're going to have e to the u times 4x to the third plus 7. And obviously we already found our u value right here. So all we're going to have to do is plug that in. Let me just erase some of this. So basically, it's just going to be e to our u power, which essentially was x to the fourth plus 7x here. So we have that u value, and then it's being multiplied by this. And that is really all it's going to be for these e functions. You're basically just going to want to write e to the u, and then you basically, once you write u, we'll see it in part B, you're going to find the derivative of whatever u is raised to. So like I said, we'll get more into that in part B, but for this e problem, when you write e to the u, the derivative of e to the u is just e to the u. So it'll just end up being e to the u. So that's why we didn't change that, but in part B, we'll see an example where we do have to change our u value. But like I said, for an exponential value like e, we're just going to want to go from eu to eu, because we also learned that in the first Hawk Tutor video, that e to the u will stay as e to the u, as e to the x will stay to e to the x. So anyways, that's part A. Now we're going to go over part B here. So to start, we're going to get going with our u value. So this can be rewritten as 25 minus x squared to the 1/2 power. So the 1/2 is just replacing that radical right there. You should always be rewriting it as 1/2. So now we're going to get our u value. So your u value is basically just going to be your outside function. So as we can see, the outside function is something, which is this, raised to the 1/2. So that's all it is. So just going to erase that. And we're going to have u to the 1/2. And now we differentiate u. So we did still have to do that in part A, but it was just e to the u, which differentiated into e to the u. But for this problem right here, it's not just going to differentiate into the, what do you call it, the same value. So basically, we're going to use our power rule, and we're going to get 1/2 u to the negative 1/2 using power rule mechanics. And from here, obviously this negative in the negative exponent is going to go down to the denominator. So we're going to end up with 1 over 2 radical u. And that radical is because it's 1/2. And then obviously it's negative, so you have to bring it down to the denominator. So we're going to end up with this for our u. And basically from here, I'm just going to rewrite it over here if we want to keep up. So 1 over 2 radical u. And now all we want to do is multiply this by the derivative of our inside function. And to define what u is again, it would just be this. U is always just going to be your inside function. So essentially, we know the derivative of this is just negative 2x. So basically, you're multiplying this by negative 2x. So that's getting multiplied right here for context. And from this point, all you're going to want to do, let me just rewrite that parenthesis, all you're going to want to do is just plug in u. So we already defined u as being 25 minus x squared. So basically it's going to be negative 2x, so we're just going to move that into the numerator for simplification purposes, over 2 radical 25 minus x squared. And then for simplification, we can cross out those 2's, so we're left with negative x over radical 25 minus x squared. And that's going to be our final answer right here. That's all it's going to be, so we're just going to box that in. And that is just essentially how you use the chain rule. So we looked over these two. And basically, long story short, you just want to get your u value, simplify that down, and then via derivative rules. And then you're just going to want to multiply by the derivative of your inside function. And always make sure to define your inside function before you start the problem, because that's basically just going to help you know how to plug in your value into u, which I just drew an arrow to right there. And then essentially just multiply by the derivative of u. So any questions, leave them down in the comments for me. I'll try to get back to those. But for now, that's it. So I'll see you guys later. Hope you guys learned from the lesson, and I'll see you guys later.